In the first session, we had some understanding about the factor analysis, and we have noted that factor analysis basically is an interdependence technique which is based on certain assumptions and uses a particular kind of a data collected by a particular by adopting certain specific techniques. And the things that are to be reported, how the factor analysis is conducted on an SPSS platform, and the things that are to be reported, the outputs, the kind of interpretation of the outputs. And we have also understood what is the basic objective or the goals of conducting an EFA. So I continuously and repeatedly stress on the fact that EFA, the first explanation is very important, or the first term, which is exploratory. So it explores. A particular researcher or a scholar, while undertaking this particular statistical procedure, is unsure about certain things which are unmanifested or cannot be directly measured. So there are a lot of constructs which cannot be directly measured. Okay, so for that you require certain surrogated, or observed variables or surrogated items with the help of which you can have certain estimate. Sorry, estimations of those, latent constructs. So EFA basically gives you the initial or preliminary factor structure, but that particular factor structure is not validated. Okay, so we need to go one step forward, and we must complete the validation process before we can accept it as a very robust kind of a model. Okay, we have only checked the scale reliability or the internal reliability of the measurement construct, and we have used one value which is called the Cronbach's alpha. So higher value of Cronbach's alpha, if it is higher than 0.85, then we can be rest assured about the internal reliability of the scale. But yes,
you are showing something.
I haven't started.
Okay.
So reliability basically is the basic difference between reliability and we often confuse between reliability and validity. Reliability basically assures about the consistency of a particular measurement instrument, where validity basically assures about the accuracy. So both are important. So in CFA, or the confirmatory factor analysis, we basically take up those validity issues. Okay, so how accurate your measurement construct is. Okay, so we are taking one step further. Now, if we go one step further from CFA, we are moving into the dependence method. So the interdependence method, where we did not have any existence of a dependent or independent kind of variable in the exploratory factor analysis. In confirmatory factor analysis also, we do not have that dependent independent kind of a thing. But if we take one step further and we try to create a structural model or a structural equation model, then we are actually assigning specific roles to the factors that have been extracted. Okay, so we are assigning certain role like a dependent factor. We are assigning specific roles to certain factors like independent factors. And then we are trying to explore the relationship or compute the relationship between the set of dependent factors and independent factors by virtue of taking up a number of, statistical tests. So you can take up hierarchical regression analysis, you can take multiple regression analysis, even the structural equation modeling will give you certain result about the predictive nature of the predictive relationship between the set of independent and dependent factors. Even if you want to take up something more advanced in nature, like artificial neural networking, it will give you certain results regarding the predictive nature of the independent factors to predict the dependent factors. Anyway, we take a preliminary look into what factor and a CFA is all about, what the confirmatory factor analysis is all about. Then we can take up the hands-on exercise. One thing I would like to mention over here, the SPSS won't help you in CFA, okay? So we have another module, which is almost an analogous module to, or plugin module to SPSS, which is called the AMOS, which the full form of AMOS is analysis of moment of structure. So with the help of AMOS, we normally conduct the CFA. So under normal circumstances, SPSS has some limitations. It limits itself to the conductance of EFA only. So when it comes to, testing for CFA, you need to take up AMOS. But I want to, if AMOS is a little bit difficult for you all to access, there is another software by the name Lisrel, Lisrel. The student version of Lisrel is open source or free to all. So you can download Lisrel and you can conduct the confirmatory factor analysis. Remember, the student version is free. Okay, there is nowadays we also use two more softwares to conduct the CFA. One is called the Smart PLS, which is again proprietary. So if anyone is having access to Smart PLS, they can also conduct CFA on that platform also. And there is one more interesting platform, which is called the Adanco. Adanco is interesting simply because of the fact the EFA and the CFA can be done simultaneously. So you need not have to do EFA first, then you take up that EFA result to conduct a CFA. So with Adanco, it can be done simultaneously. So Adanco has one added benefit. It's a drag and drop kind of a operation. So that is another benefit. So you need not have to run anything separately. Just drag and automatically the analysis takes place. Anyway, today we will take the help of AMOS, which is a plugin part of IBM SPSS, to conduct a demo kind of a CFA. Fine. So let us first try to understand what exactly is the difference between an EFA and a CFA, having understood certain preliminary facts about EFA. So what EFA does, it determines the factor structure, the underlying factor structure, which is not which is not evident, which is not revealed to the researchers when the researcher is starting the research. So, but the researcher is having an understanding about this kind of the existence of this kind of a factor structure. So the researcher's initial objective is to explore what kind of a factor structure does exist. So with the help of certain scale items, with the help of certain observed variables, he or she proceeds with the initial exploration before he or she comes to the extraction of the factor situation and the factor structure is identified. Whereas, in CFA specifically, we require a priori model. That means there has to be a model beforehand which needs the validation. So whatever the output of the EFA becomes the input for CFA. Okay, so EFA, if it is churning out a measurement model, that becomes a priori model for the CFA for validation purpose. Okay. Now EFA basically becomes operationalizable based on the fact that it explains maximum amount of variance that we have seen. The fundamental ideology of EFA is how it can explain the maximum variance in the model, whereas CFA it specifies the number of factors and the number of measured variables. Okay, and CFA, if you do not conduct the EFA, if you directly want to go ahead with the CFA, you need to have a model which is supported by a theory or a previous research. So you can take a model which is untested or unvalidated, which has been done by some researchers earlier, and you are taking it up for further validation. So either you require a priori model which may come from a EFA that you have conducted. In most of the cases, scholars are doing EFA first, and then with the output model, they are proceeding for conducting a CFA for validating that particular model. Or if a particular researcher or a scholar is interested to take up certain model which is unvalidated, which has not been tested, which has not been confirmed. So a model which is supported by a theory or by certain kind of propositions, working hypothesis, or any other kind of previous academic research that can be taken up, and it can be used for a confirmatory factor analysis. So this is the fundamental difference between the exploration of factor analysis and the confirmation of the factor analysis techniques. So what are the steps in confirmatory factor analysis? First one is to define the individual construct of the measurement model. Define of the individual construct. That means when we talk about the individual construct, it is the latent construct or the underlying factor structure that has been discovered while conducting the EFA. As an output of EFA, you can say that underlying factor construct has been identified. So we need to define the individual construct of the measurement model. The second thing, specifying the overall model to be tested. So you have to, draw out the entire model, the measurement model that has to be tested, how the covariants are, aligned, how the, the observed variables are linked to the latent variable. The entire structural, the structural part has to be drawn. Estimate the empirical results of the measurement model. Then we try to assess the validity of the measurement model. So while assessing the validity, we are trying to assess the discriminant validity, we are assessing the construct validity, we are assessing the nomological validity or the face validity of the particular model. For three specific validation, basically the discriminant and the construct reliability are assessed on the basis of the average variance extracted, or the construct reliability, or the construct validity, etc. So the first one, it's a four-step process. Define the individual construct of the measurement model, specify the overall model that is to be tested, then the estimation, the empirical results of the measurement model, run the test virtually, and then you validate the entire thing. Now, let us understand fundamentally certain issues which may crop up during conductance of this CFA. So the first set of things that we need to understand is the difference between a congeneric and a non-congeneric measurement. Then we need to understand the difference between a formative model and a reflective model. So in whether Amos can handle both the formative and the reflective model, that is a big question, because Adanco as a platform, it can handle both the formative and the reflective model, while Amos is having certain limitations. It cannot deal with certain kind of a formative models. And then we need to ask a question that how many observed variables should be there for the perfect measurement of a latent construct. So each latent construct needs to have how many supportive observed variables. Okay, so that thing has to be understood also. But let us first take on this congeneric and the non-congeneric measurement. So in this particular construct, you see, which is known as the congeneric measurement, you see the construct or the latent factor, which is represented by this elliptical shape. This is the latent construct, and this latent construct is having four observed variables linked to it. So there is x4, x5, x6, and x7. Okay. Now you see the interesting thing of for this particular model, and let us take both the things simultaneously so that you can understand it better. So if we go back to here, see why it is called a congeneric measurement, because there is no cross loading. You see, this single observed variable has been loaded on a single construct. This observed variable on a single. See, there is no second construct. As you can see in the non-congeneric measurement, this will give you ample explanation. you see there are two constructs over here, two latent constructs or two hidden constructs. Okay, so we have x1, x2, x3. There are three observed variables that measure this construct, and there are four observed variables that measure this construct. Okay, but interestingly, what has happened here, that x2 as a observed variable is loaded onto this particular construct. You see x2 is also loaded on this particular construct. Similarly, x4 is defining this construct, x4 is also defining this particular construct. So there is a cross loading. Okay, so if this kind of a measurement surfaces, or this kind of a measurement crops up, whereby one particular or more than one particular observed variables are significantly correlated with more than two, latent constructs, then we are supposed to get, or we are in our hand, a issue which is called a non-congeneric measurement. So congeneric measurement or congenericity basically assures that a single observed variable is significantly correlated with a single latent construct, whereas non-congenericity explains or focuses on multiple number of observed variables having multiple number of correlational kind of a situation with multiple number of constructs. Anyway, non-congenericity is not at all desirable, because that will not make your model very robust, and interpretability will be a big issue. The next question that often we face as researchers or as supervisors, that most of the scholars are coming out with this particular question, that how many scale items, how many observed variables should define a construct? Is there a rule of thumb? Is there any formula? Is there any way to understand that how many variables should define a particular construct? Now, to answer this question, we need to understand that there can be three different types of model. Okay, so one can be an under-identified model, the second one can be a just identified model, and the third one can be an over-identified model. Now, which one is preferable? Obviously, the under-identified model is not preferable at all. So at minimum, you should have a just identified model, or at best, you can have an over-identified model. Now, let us have an understanding about these under-identified, just identified, and over-identified model. See, there has to be a comparison, or there has to be a relational, issue between number of parameters to be estimated while conducting a factor analysis and the output of symmetric covariance matrix of those observed variables. So on the left hand side over here, you see there is a single latent construct. Okay, so for this single latent construct, there are two observed variables. So these two observed variables are responsible to define this latent construct. So A1 and A2 are observed variables. So how many parameters are here to be estimated? So if I run an application, or if I run the software of SPSS, how many parameters will be estimated over here? Number one, lambda 1, number 2 is lambda 2. So these are the correlational values that will be churned out, two parameters. So two parameters, lambda 1 and lambda 2. And two more parameters, the error variance E1 and E2. So number of parameter is 4, okay, for this very simple kind of a construct. Now, if I come to the symmetric covariance matrix involving the observed variable, so the correlation between the observed variables, so how many, output values we are getting? So A1 correlated with A1, we are getting a value. A2 correlated with A1, we get a value. A2 correlated with A2, we get a value. So if it is the case that the number of parameters to be estimated, if it is greater than the values that is churned out by symmetric covariance matrix, this will be an under-identified model. Okay, so let me just repeat it. The number of parameters that is to be estimated, say over here, the number of parameters that is to be estimated, is 4. Lambda 1, lambda 2, correlational scores, E1, E2, the error scores. Okay, so 4 parameters are to be estimated. But In the symmetric covariance matrix, we are having three output values. So 4 greater than 3. If the number of parameters to be estimated is greater than the output of the symmetric covariance matrix, the model becomes under-identified. So, in other words, we can say that if we have only 2 observed variables, which with the help of which we are trying to define a construct. See, it is not in your hand, it is not within your control that how many variables will be ultimately retained by the factor solution. Because once you run the EFA, once you run the exploratory factor analysis, everything depends on the algorithm and the software, because they will determine the best possible model, and the best possible model will be retained. So at the end of the EFA, if you see that only 2 observed variables have been retained to describe a particular latent construct, then you can easily come to a conclusion that this particular construct measurement is not robust at all, not very dependent at all. Okay, because this becomes a part of your under-identified model. This is not desirable. So 2 observed variables measuring a particular construct is an absolute no-no. So let us see what happens in a just identified model. Over here, you see this particular latent construct. For this construct, we are having 3 observed variables, A1, A2, A3. So how many parameters are to be estimated? 3 correlational scores between 3 observed variables and the latent construct. So lambda 1, lambda 2, and lambda 3. And we have 3 error scores also, E1, E2, and E3. So how many? 6. 6 parameters are to be estimated in this particular model. Now, if we come to the symmetric covariance matrix, there are 3 observed variables. So if we conduct a correlational covariance matrix over here, you will get 6 outputs. So A1 with A1, A2 with A1, A3 with A1, A2 with A2, A3 with A2, and A3 with A3. So 3 plus 2 plus 1. So we are getting 6 values. See, number of parameters to be estimated is 6. So number of values that are churned out by the symmetric covariance matrix is also 6. So if the number of parameters equals to the number of values churned out by the symmetric covariance matrix, it is a just identified model. We can accept it. Okay, it is just. That means this is the bare minimum requisition. So now you have got answer to your question that how many observed variables are required to actually retain a latent construct in your EFA model. Because you see, you can put forward an EFA model for CFA, the confirmatory validation for validation purpose, you will not find very good result in the validation. Why you will not find very good result in the validation indices? Because if we go back to the earlier slide, and if we retain this particular model, and if we put forward this particular model for validation, we will not get good result, because this is an under-identified model. This is not a very robust or a very strong kind of a model. So the validation indices will be very poor. The GFI, the goodness of fit indices, or the badness of fit indices like RMSE, root mean square error approximation, or RMR values will be quite high. So ultimately, that model will not be a very robust kind of a model. You can retain it for academic purpose, but ultimately that model will not have any significant relevance to social implication or implementation of that model for certain social cause. So you should start at this level, and the retention of a particular model should start from here. So at least there has to be 3 observed variables per latent construct. Okay, so that gives you a bare minimum requisition for the number of observed variables. But as I have told you, you do not have full control over it. So you can ask how to ensure. That's why we always say that the number of variables to start with should be always on the higher side. If you are starting with only, say, 10 or 12 observed variables, then it will be very difficult for you to ensure at least 3 numbers of observed variable per extracted construct. Okay. On the other hand, if you are starting with say 60, 70, or if you are going on a very higher side, even if not that, if you are having a set of 25 to 30 observed variables, and then you can expect a sizable number of allotment of observed variables per extracted construct. So there you will not face any issue of under-identified model. Now let us see what happens in the over-identified model. In case of an over-identified model, the number of say observed variable is say 4. Okay, A1, A2, A3, and A4. So how many parameters are to be estimated? 4 correlational parameters, lambda 1, lambda 2, lambda 3, lambda 4, and 4 error parameters, E1, E2, E3, and E4. So the number of parameters to be estimated is 8. Now let us see the symmetric covariance matrix. There are 4 observed variables. So the covariance matrix will churn out how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you see the number of parameters to be estimated is less compared to the symmetric covariance matrix value. This is the ideal position. So if you are having such construct, such extracted factors, which are having support of at least 4 observed variables, that model is considered to be very good and very robust. And if you proceed further to evaluate that model, and if you proceed for validation of that particular model or to find confirmation of that particular model, you can actually be very confident about this. So if you are having 4 observed variables per construct, so we started with a very fundamental question over here, that how many items or how many observed variables should define a construct. So for an under-identified model, you will have a very poor validation. Okay, for a just identified model, you have a validation model which may be accepted, but only just. For an over-identified model, you will have a very low, robust kind of a validation. That's for sure. Okay, so this is the second thing that we wanted to discuss, and the third issue is the difference between the reflective and the formative models that we were talking about. Okay, so what is the difference between a reflective and a formative model? Let's just take an example and then you can have a certain understanding. Now you see, this is the layout of a reflective model. So we have a set of observed variables, like these are observed, like fever and chill. We have an observed variable like headache, cough and tiring, or stressness, or fatigue, or something like these are all observed variables. Okay? So we can actually measure fever, we can have an understanding about the intensity of the headache, we can have an understanding about the intensity of cough. Similarly with tiredness, to what extent you are tired, you can have certain understanding. And these are, in case of a reflective model, the latent factor, here the latent variable is this one, which is called the viral attack. Okay, this is the latent variable. Here the latent factor is basically independent. Okay, the latent factor is independent, whereas the observed variables are dependent and are highly correlated with each other. Okay, so we cannot have a direct understanding about a viral attack, but we can actually go one step ahead, and we can say that a person is under a viral attack if we see some of the manifested symptoms, isn't it? So these are all the manifested symptoms. The fever and chill is a manifested symptom. Headache is a manifested. We can actually observe it, but we cannot observe viral attack directly. These are the surrogated observations, or the surrogated, you can say, expressions with manifestations with the help of which we can interpret. A doctor can understand that probably there is a viral attack. So fever and chill and headache and cough and tiring, etc., that is a sign of a viral attack. So this is a reflective model whereby the latent variable or the latent factor is independent and the observed variables are dependent and are correlated with each other. So let us now look at the formative model. This is the formative model. In case of a formative model, this is the latent construct, the heart attack. The latent factor is dependent. Now it is dependent on what? It is dependent on the observed variables. Okay, say consumption of alcohol, that's an observed variable. Alcoholism is an observed variable. Emotional stress, that's an observed variable. It's responsible for heart attack. Diabetes, it's a comorbidity condition, a particular condition for a distressed physical condition, and then a particular habit, okay, which is called smoking. So all these four, observed variables are independent. They are not related to each other. Okay. Say smoking is not actually related with alcohol. Okay. So we cannot, it can be a fact, or it can be an observation that the person who is a compulsive alcohol consumer is also a prolific smoker, but apparently you cannot establish a correlationship with them. So all these observed variables are very independent of each other. Okay, a particular diabetic person may not have the habit of consuming alcohol. So diabetes is not alcohol dependent, or alcoholism is not mandatory to induce a condition of diabetes. So in a formative model, the latent construct or the latent factor is a dependent one, and the observed variables are independent in nature. So this is the nature of the formative model. Now we proceed for the estimation of empirical results of measurement models. What are the estimations that we need to take up? Number A is the identification, the order condition, and the rank condition. The order condition says that the unique variance and covariance should be greater than the number of parameters to be estimated. That we have already seen, isn't it? The symmetric variance output should be greater than the numbers of parameters to be estimated. That should be the ideal condition. And the rank condition is the minimum 4 items per construct. That we have already understood. For an over-identified model, that has to be understood. Number B, assessing the validity of the measurement model. The fit indices, particularly the GFIs, the goodness of fit. The incremental fit measures, that has to be understood also, that has to be tested and interpreted, and the parsimonious fit measures. Now, along with the goodness of fit, what are the goodness of fit indices that we will see when we will take up one example and we will apply a MOS. So GFI, then the AGFI, the adjusted goodness of fit indices, or TLI, the Tucker-Lewis indices, and the CFI, NFI, the normed fit index. These are all the the goodness of fit indices. The cited value or the referred value is always greater than 0.9. Okay, so to have a very robust kind of a model, or to have a very good validation, or to accept it as a validated model, you should have the GFI values greater than equal to 0.9. Similarly, we have sets of badness of fit indices also, whose values should be relatively lower, considerably lower. Say, for example, one of the badness of fit indices is the RMSEA, the root mean square error approximation, whose value should be maximum 0.05, or it's good if the value is, say, 0.04. Then the RMR value, again, it should be anything between 0.04 and 0.05. So all of these indices, if they fall into acceptable limit, then we can say the validation or the robustness of the model can be accepted. Now, we will often talk about different kinds of validity that we have already said, like the construct validity. The construct validity, basically, it focuses on 3 different kinds of validity. One is the convergent validity. The first indication of the convergent validity, that it should be having a factor loading of greater than 0.7. You remember in the Efa session, when I was suppressing the smaller values, I was assigning a figure of 0.6. I said that it should be the minimum, that anything below 6. 0.6 means what? What is factor loading? Factor loading basically is the correlational score between the observed variable and the latent construct or the latent factor. So any correlational score which is lower than 0.6, it should not be Hello, brother.
Yes, yes, sir.
Okay.
Yes,
Sorry
yes.
for that.
We have electricity problem here.
Yeah, there is a power cut. So anyway, just okay. Let us just take this up quickly. I do not know how. Anyway, so we were talking about this construct validity. So construct validity can be measured with the help of three. It basically focuses on three issues. One is the convergent validity, which speaks about the factor loading. Factor loading, as we have understood, it's the correlational score between the observed variables and the latent construct. So it should be preferably greater than 0.7. The second one is the average variance extracted. It should be greater than 0.5. So if we just look into what observed variance extracted, average variance extracted is, it's represented like this. Okay, so it's a pretty complicated kind of representation. Let me just give you, if you see this particular equation, you will find it's a summation of I is equal to 1 to k lambda I square divided by summation of I is equal to 1 to k lambda I square plus summation of I is equal to k variance Ci. Now, basically, what does it suggest is the k represent the number of items. Lambda I is representing the factor loading for I item, for the item I, and VAR EI, that is basically the variance of error of item I. Okay, so this is the average variance extracted, which we can represent with the help of an equation. So this is one of the indices for assessing the validity, and the accepted score for average variance extracted should be greater than 0.5. Then we have the CR, or the construct reliability, which should be greater than 0.7. We go for the discriminant validity also. The measurement of the discriminant validity is the average variance extracted between any two constructs should be greater than the sum of squared correlation between the two constructs. So these days, you need not have to, calculate or compute these things manually, although these things can be manually done also. But you have certain statistical packages with the help of which you need to, give certain inputs, like the correlation matrix or the correlation results and the regression weights if we give input, and then these validity indices are automatically calculated or computed. Okay. So these are the few issues which are associated with CFA. Now, if we can just proceed with one particular example, and we will see the operation with the help of AMOS. So in CFA, we are using a measurement model which has been churned out by EFA, and we are putting that model for validation under CFA. So we will test the construct validity basically through convergent validity. We will estimate the factor loading. We will have average variance extracted. Now you see the factor loading is basically need not be tested at the level of CFA, because you only proceed for CFA if you find that the factor loadings in EFA are considerably high. That means higher than 0.7. What we will test is the AVE, that's 0.5, the construct reliability, which should be greater than 0.7, and the discriminant validity, the AVE between any two constructs, which should be greater than the sum of the squared correlation between the two constructs. In case of the discriminant validity only, you can go for a manual calculation or manual computation based on all the scores that you will be receiving from automated computation. Okay, so let us go for one example. Since we are focusing on, I do not know whether I will be able to show you the structural model also. Let us just focus on the measurement model. So we are using, as we have said, if we go back to the first slide, over here, the difference between EFA and CFA, you see one of the features of CFA is this third point, a model supported by theory or previous research. Okay, so if you have some model, if you have some theoretical support to a particular framework, if you have certain theoretical support to a particular model, then you can use it. So we are actually using a theory which is well established, okay, which is called the theory of planned behavior. This is one of the behavioral psychological theory which is extensively used in studying the consumer behavior and consumer decision making process. And there are 5 latent constructs which were identified with the help of this theory. Okay, so the first is attitude of the consumers. The second is the subjective norms which are guiding and helping you framing decision. Certain behavioral control factors, which is called the perceived behavioral control. Then your intention to purchase as a consumer and your post-purchase behavior after purchasing a particular commodity or particular goods. Okay, so this is the theory of planned behavior. It was constructed by Fishbein and Eisen in 1980 and subsequently revised in 1985. Actually, in 1992, this particular theory was altered. It was renamed, and it was renamed as theory of reasoned action. So a lot of changes took place during that particular period. Anyway, so if we consider this as a grounded theory, or if it as a theory which is the foundation for our CFA, we have 5 latent constructs, and these 5 constructs are having certain observed variables also, because these are latent constructs which were identified with the help of an EFA. So we have already conducted the EFA, and we have got these latent constructs. Now let us see the observed variables. Okay, so attitude was measured with the help of these 4 variables, 4 observed variables. Subjective norm was using these 3 variables. Perceived behavioral control, 4 observed variables. purchase intention, 3 observed variables, purchase behavior, 3 observed variables. Now, you see, as I've told you that 4 observed variables for attitude and 4 observed variables of perceived behavioral control, both these two things are giving you an over-identified model. So there is no issue. But subjective norm and purchase intention and purchase behavior, these 3 latent constructs are just hanging by the thread, isn't it? They are only just identified. So in the process of validation, if one particular observed variable is discarded, then this particular part of the model becomes under-identified. So it will be causing certain validation issues. Okay, so with that understanding, let us proceed with this process. Okay, so let me just open the Amos platform. This is the Amos. Let me just have. Okay. So this is the Amos platform, the IBM Amos, which is an SPSS plugin actually. So you see on the left hand side there is a navigational panel with a lot of tabs. There is a horizontal navigational toolbar over here, and we have a working space. It's like a canvas over here, so we can do things over here. So all the structures that you draw, all the measurement models or the structural model that you draw it in this particular canvas. So all these tools will basically help you to draw the structure and put certain estimation, etc., etc. Okay. So let us go back to our original proposition or the example. So how many latent constructs are there? There are 5 latent constructs, okay? And for 5 latent constructs, we have certain observed variables. So attitude has 4, as I have told you. Then the subjective norm has 3, perceived behavioral control has 4, purchase intention has 3, and purchase behavior is having 3. So let us draw the let us draw the measurement model first. Okay, so come to the left hand side navigational panel. You see this is a flower like structure. My cursor is hovering. Each of the latent construct is represented either by an elliptical shape or by a round shaped, okay, a round shape, okay. And each of the latent construct are connected to the observed variable. So the number of observed variable that are already assigned will be taken up over here. So you just click it, this particular tab, you just click it and bring it over here in the canvas and click it once. Okay, so you will get a circle. This particular circle represents the latent construct. Now, how many observed variable was there for attitude? This is the first latent construct. The first latent construct was attitude for that particular theory. So how many observed variables? There were 4. So you tap it 4 times. 1, 2, 3, 4. So you will have these 4 observed variables connected to this latent construct. Now there must be good visibility. There must be certain cosmetic changes, certain beautification, so that it looks nice. So you again go to this left hand side navigation panel, and you see this is a semicircular kind of tab icon. If I select it, this will rotate this entire thing. So I'm just going to click it. Okay, the first click, it will rotate it 90 degrees. So it will come over here, then another 90 degree, then another 90 degrees. So let me drag this entire figure into the canvas. See, a part of the figure is outside the canvas. Let me drag it. Now again, come to the left hand side of this navigation tool. You will have one flower bouquet like structure over here. My cursor is hovering here. A flower bouquet like structure. This flower bouquet, if you select it, it will keep the entire drawing under selection. Okay, this is selected. It keeps the drawings under the selection mode. Okay. Now I want to drag it inside the canvas. So what can I do? There is a truck-like structure over here. This is a vehicular structure. Okay. So the vehicular structure is selected. I am bringing it here. This is almost like a transportation. So I'm just dragging it. You see the entire figure is now within the canvas. Okay. So I can also just make certain little adjustment. Okay. Now what I can do is I can actually expand these boxes also if required. So there is a tab over here. You see a blue colored tab. So if I click it, I can actually manipulate these boxes. So I can make it a little bit enlarged in size. Okay. So this is the first, modular representation. The latent construct is attitude. I will populate with the textual part later. So let me draw the entire thing, then I will just populate with the texts. So this is the latent construct, that is attitude, and these are the four observed variables. And these small circles which are attached to these observed variables are the error terms, right? Now let us go and put forward the next latent construct, which was, I think, subjective norms. So subjective norms was having three observed variables. So I'm again clicking on this. This is the latent construct representation. So this is subjective norm 1, 2, and 3. Fine. So there are three observed variables connected to it. Going to the navigational panel on the left hand side, again clicking on this circle, and I'm rotating this using the truck or the transportation for, sorry. Let me just rotate it. Deselect this one, select the truck, and I'm just going here. And let me have a little bit of adjustment with the boxes, rectangular boxes. Let me make it of similar figure. Fine. And let us deselect it, select the truck again, and let me make a little bit of compression and place it over here. So I have got two latent construct in this measurement model. The first one is the attitude. The second one is the subjective norms. What is the third one? The third one is the perceived behavioral control. So perceived behavioral control was having four observed variables. So 1, 2, 3, and 4. So let us rotate it. So you can rotate this, deselect it, take the transportation, put it back here. Okay, select the square adjustment, make the square adjustment, deselect it, select the transportation, and then make a little bit of compression, then adjust it over here. So you have to make adjustment of the spaces because a limited space is available in the in this particular canvas, and so you need to utilize it well. Okay, so let us use the third construct, latent construct. It is called the purchase intention. The purchase intention was having three observed variables. So let us use the rotation factor. So it has been rotated, deselected, take the transportation, you drag it over here. Okay, so you just resize the boxes and deselect it, select the transportation, you make certain compression, you make certain realignment. So the space is adjusted, and now we want to bring in the last. Okay, so the last one is the purchase behavior. It has three observed variables. So let us rotate it and then deselect it, take the transportation and bring it over here. Okay, so you see, had I, considered another latent construct, I would have struggled to adjust it in this particular place, in this particular space rather. So probably at that time, I probably I had to squeeze out a little more. So use this to adjust the squares a little bit. Then deselect it, use the transmutation to make certain compression and do it. So you see, our fundamental measurement model is drawn. Okay, so how many latent constructs we are having? 1, 2, 3, 4, 5, and so we are having 5. 1, 2, 3, 4, 5, and we are having also for the first latent construct, we are having 4 observed variables. We are having 3 observed variables for the second latent construct. We are having 4 variables for the third latent construct, 3 for the fourth, and 3 for the fifth. Fine. Now, I haven't imported any data yet. Okay, so let us just import a data, because you see, with regard to all these variables, I have gathered data. Okay, so these were part of my questionnaire. So against each of these particular item, I have generated a score. I have used a Likert scale and I have generated a score. So let us just visualize that score first. Okay, so there is a a file which is called the TPB file, Theory of Planned Behavior. Let us see it. Then you will understand. Just give it a second to open. Fine, let's see the data view. So how many data I have collected? I have collected 300 responses. Okay, so how many variables I was having? I was having 17 variables. So for attitude, there are 4 observed variables. For subjective norms, there are 3. For perceived behavioral control, there are 4. For purchase intention, there are 3. And for purchase behavior, there are 3. So 17. So what is the rule of the thumb? Rule of thumb, 17 into 5. So 85 was the bare minimum necessity for sample. But I have collected data from 300 samples. So it is more than enough. So I have labeled it over here. All the labelings have been done. And they are all scale data. They are all input data, right? So this is the data that I need to, import in Amos. Okay, so this is the Amos platform. I need to import the data. So what should I do and how should I do that? You see, my cursor is hovering around a particular tab, which looks almost like a data tab. So if you click this, it will open this kind of a window. Okay, so I need to show the file path. So you just click this file name for importing of the data. Okay, this is the TPV that I just opened. So select it, open, and just press OK. The file is imported. Now, how will you find that the file has been imported? Okay, so you see this particular tab over here, you just click it once. Now, just drag it here and dock it here. Okay, so this is the file that I have imported. So I am only interested about the variables. Okay, the data will be automatically taken up, but I am interested about the variables. Fine. So the variables, this 81, 82, 83, 84. So these are 4 observed variables for the latent construct attitude. SN1, SN2, SN3. These are the 3 observed variables for the latent construct subjective norm. PBC1, PBC2, PBC3, PBC4 are the 4 observed variables for the latent construct perceived behavioral control. Purchase intention, PI1, PI2, PI3, 3 observed variables for the latent construct purchase intention. And PB1, PB2, PB3, these are the 3 observed variables for the latent construct purchase behavior. Okay, So I now need to shift each and every item over here. So these are, as I've told you, these rectangles are representations of the observed variables. These circles are representation of the latent constructs. These small circles are representation of the error variables. Okay. So 81, I am dragging and dropping it over here. Now you see the main problem is, as soon as I am dragging this, it is assuming the entire sentence which is associated with this item. So I do not need this entire item. This item has been coded with the help of a specific code named 81. So I need only this 81 inside this particular box. I do not need the entire item, explanation of the entire item or the explanation of the entire variable. This will make the things very clumsy. So just undo it. So what we can do is, just to get these 81 inside this box, if you are doing it for the first time, the entire sentence will be taken. So there has to be a little bit adjustment. So you click this view, okay, this view tab, you click this, and then you click this interface properties. This is at the top. Okay, so view, interface properties. You see the interface property is having multiple number of tabs. You only come to this tab which is called MISC, miscellaneous. Okay, you just click this tab. By default, this box will be checked. Display variable labels. This box is checked. Just uncheck this box. Okay, apply. So what I have done, I have gone to this view and I have clicked this view and I have clicked this interface property. Interface property will just sprout this particular window for me. You go to the miscellaneous tab. By default, this window, this particular box will be checked for display variable labels. So you just uncheck it, apply it, and then simply close it. Now you see, if you drag 81, it will be 81. Okay, so no full sentences will be dragged. So 82, you just simply drag and drop. 83, it's that easy. Operation for Amos is very easy. SN1, SN2, SN3, and then PBC1, PBC2, PBC3, PBC4. So all the observed variables are brought in. Okay, all the observed variables basically are labeled. So PB1, this is the last one, PB2, and PB3. Fine. So all the observed variables are labeled. Now you can actually close this box. It's no requirement. So all the observed variables are populated. Fine. Now I need to label the latent constructs. Okay. So I have attitude. So how you can do that? You just double click it. Okay. On this latent construct, you double click it. So as soon as you double click it, there will be a window which is called object properties. So this object properties, you simply type in the variable name. In this particular window, you type in the variable name. So attitude. You see, the attitude is already typed in here. Bring your cursor and click on the second construct. It was objective norm. So it has been typed in over here. Bring it to the third cursor. Perceived behavioral control. Bring it to the fourth one. Purchase intention. Bring it to the fifth one. Purchase behavior. Okay. Fine. So all the latent constructs were named: attitude, subjective norm, perceived behavioral control, purchase intention, and purchase behavior. Now only one thing is remaining as far as populating this particular measurement model is concerned. We need to populate the error term. Again, just double click it. error term E1, E2, E3. Just click and go on typing. So this is very easy. So you need not bother have to. You need not have to bother much about this. E5, E6. Just click on to this error term and just type it out. E8, E9, E10, E11, E12, E13, E14, E15, E16, and E17. Fine. So you can close this object property box. Now you see our measurement model is almost ready, but it is still not ready. But the textual part or populating the measurement model with textual content is almost over. So the labeling part is done. So we have labeled the observed variables, we have labeled the latent constructs, and we have labeled the error terms as well. So you can make certain adjustment with the help of this magic wand. It is done. Anyway, one important thing is there is to assign the covariance structure. Okay, so these latent construct, they may covary. So all the covariance structure has to be drawn. Now there is there can be, you see, you can select this particular double-headed arrow, and you can just select it, and you can draw like this all the covariances. Okay, you can draw it like this. This is a manual process that I am following, so it can be a bit clumsy. It can be okay. So in this way you can draw it out. Okay, it is done manually, or you have another option. Let me just it has assumed. Fine, this has taken the shape. Anyway, you could have done another thing, which is called, you go to these plugins and draw the covariances. Okay, you click this plugin, and there is an option called draw covariances. You can do that also. For that, what you need to do, you have to select one of these latent constructs. So from where the covariances will be originating. So at least one construct has to be selected. Okay, so let us select all the constructs. So this is a selection tool, this one finger raised, you are clicking this. So let me just select all these latent construct, and then I'm going over here, draw covariances. You see the covariances are drawn. Now I can go here and I can actually select this, and I can actually drag it over here. Fine. And deselect it. So all the covariances are drawn. Fine. So this particular structure is drawn. So you can go for a manual, drawing, or you can go for a plugin. You can use a particular plugin. So let me just finish this structure with a manual kind of drawing only, so that there is no duplication. Now, one more important thing, if the manual drawing is not that good, you can always use this particular tab, which is called a magic wand. This makes certain cosmetic changes, and it gives you a nice shape. Okay, so if there are certain anomalies, it will be wonderfully tackled. Now your measurement model is ready for testing. Okay, it's ready for testing. So what we now need to do is we need to specify our output. So what exact output we require. We are testing the measurement. Remember, that we have already conducted the EFA with the help of these data, the TPB data. Now we are testing the measurement model that has come out of the EFA. So you now pretty well understand that the EFA has given us this structure, isn't it? EFA has churned out a 5-factor model. These are the 5 components or 5 factors that has been extracted and retained by the EFA model. So what we are doing in CFA, we are just validating it. We are just checking whether it is a valid model, is it a robust model, can we retain this model for further studies, can we, if it is a scale, can we use this scale for any kind of a survey, can it be considered as a very robust, very powerful survey instrument, etc. So we are actually checking the validation issues. We have already checked the reliability because we have got the convex alphas, probably when the CFA was conducted already convex alpha was checked, I'm sure. So now we are checking the robustness of this particular scale in terms of its validation. So over here, you see my cursor is around here in this second tab in this particular row. So you just click it and go to the output. So what output we require? So we require the standardized estimates, we require the squared multiple correlations, we require the factor score weights, we require the covariances of estimates, the correlation of estimates. For the time being, it will be enough. Okay, so we require these estimates that will, bring out all the GFIs and the AGFIs and the badness of fit indices, etc., etc. So now the model has been specified, the model has been labeled, the covariance matrix has been drawn, the output has been selected, the output has been already selected what kind of output we require. Now we want to test it, we want to run this particular model. Okay, now for running this particular model, we need to click this particular tab. Okay, now as soon as we are clicking this particular tab, you will find one message will pop up, that is, you cannot run this operation without saving it first. So it will provide you with an option to save this particular model and then you can run it. So let me just click it. You see, it is just asking me to save it. So I'm just saving it by demo3 save. Now you see this has run and this is completed. Now how to see the result? You see there is an indication whether the process has run successfully or not. How you will know that the process has run successfully or not? You see there is a tab over here which was deactivated so far. Now as soon as this process runs, and if it has run successfully, this this particular tab will be activated and a red arrow will be shown. Okay, this red arrow will be shown. Now I have 2 sets of results over here. You can see I have 2 sets of results. One is unstandardized estimates. So if I click the unstandardized estimates, you see all the values over here. Okay, all the lambda values. These are the correlational values between the observed variables and the latent construct. And these are all the covariance values we are having over here. Okay, and then we can have the standardized estimates. If we click on to these standardized estimates, we will be, these are the unstandardized estimates, these are the standardized estimates. Okay, now from where we can get the entire result in a text format. So the entire result, to get the entire result in a text format, we can check one more box over here. You see, in this particular box, a lot of information you will get. So there are 300 cases. Okay, so there is a default model that we have already churned out. We will get a chi-square value over here. It is 2860.6 with a degree of freedom of 112. So minimum was achieved. If minimum is not achieved, the iteration is concerned, then the model would not have displayed and this particular tab would not have been activated. Okay, it would have remained in a very passive mode. Now I want to find out all the test results. So from where the test results will be found? See, this is a particular tab. Okay, just on the left hand side of the save button, there is a tab. So if I click this tab, all the test results will be found here. So on the left hand side, you will have all the result heads. If we go on expanding, then you will have all the results. Now you see number of distinct parameters to be estimated is 41. Now number of distinct parameters to be estimated is 41. So from where this 41 is coming? Okay, from where this 41 is coming? So we are having 17 error terms. Fine. We are having 1, 2, 3, 4. We are having 17 correlational values. So that is 34. And we are having, 7 covariance matrices. So we are having in total how many? 34 plus 7, that is 41. Now let us see the estimates. Okay, let us see the estimates. So you can click on the left hand side. Over here you will find the analysis summary, you will find the variable summary, you will find the estimates, you will find the scalars. In the scalar, this is the most important section, because under the scalars you will find the regression weights, you have the standardized regression weights, you have the covariances, you have the correlations and the variances, the squared multiple correlations. So you have a lot of things over here which will be very important for checking the validation. Okay, and then you will have the model fit, the GFI, AGFI, etc., etc. Okay, so that is also there. Fine. So let us first go to the regression weights, but we are normally dealing with the standardized. This is a very important thing, the standardized regression weights, but we will come to it a bit later, because we will be using two very important things from this particular estimate. One is the standardized regression weight, and the second one is the correlation. Okay, so this is the correlation that we have got result, and the standardized regression weight. We will be using these two tables later. But let us see the model fit, whether the model is a good one or not. Okay, now you see, if I come over here, what you see, the GFI. The GFI score is 0.595. That is very poor. Okay, that means the model is not good at all. The AGFI, very poor, 0.447. You see the CFI, 0.556. You see the TLI, 0.461. NFI, the norm fit index, 0.548. So the 5 goodness of fit indices that are normally reported, like the GFI, AGFI, the Tucker-Lewis index, the CFI, and the norm fit index, all these are having very poor scores. So we cannot say, probably the data set was having, see, the indications must be there when the EFA was conducted. You see, CFA will only assess the EFA model. So all the problems, all the issues, all the limitations, all the difficulties must be identified by the scholar at the EFA level, because when you are proceeding for CFA, that means you are confirmed that the EFA model holds good. But if this kind of validation results are coming up, there must have been some problem with the EFA result which was neglected. Okay, so this is one way to check the robustness of the model, to assess the goodness of fit indices. I told you that along with the goodness of fit indices, there is also badness of fit indices. Okay, so there are two values. One is called the RMSEA and the second one is called the RMR. So let us see the RMR value. RMR value is 0.374. It is way too large. Okay, the acceptable range of RMR value is 0.04. 0.374 is way too large. So the badness of fit indices is also not supporting this particular model to be a very good model. Let us check the root mean square error approximation, the RMSEA. RMSEA value is 0.286. That is way too large again, because the RMSEA acceptable limit is 0.05. It is very good if it is round about, between 0.04 and 0.05. But if it is 0.286, unfortunately, this model cannot be expected. As I have told you, see, in the next stage, when we will be conducting the validation, the average variance extracted, that is one of the validation issue. The construct reliability to be checked, that is another validation issue. The discriminant validity to be checked, that is another validation issue. If you see that validation is not a problem, that means the model has been validated. I told you when we discussed about Efa in the first session that statistical significance may be achieved relatively low. Okay, so validation may be done. Okay, the model can be validated, but the model itself is not that strong. Okay, we can actually not, we may not use this model as a very robust model. We cannot make any practical use of this model. Academically, it may be very sound. Academically, it is a validated model. Theoretically, it may be a very validated model. But when this model will be used to explain something, because we are trying to explain consumer behavior. So in real life consumer behavior or real life consumer purchase decision process or post-purchase behavior, explaining the purchase intention, etc. When we will be applying this particular model, it may not be that robust in explaining all these, behavioral pattern of the consumers. But as I have told you, that statistical significance may have been achieved. The validation part may be achieved. Okay. So all these goodness of fit indices and badness of fit indices, unfortunately, they do not conform the fact that this model is a robust one or this model is a good one. Okay. So when you are reporting CFA in your journal paper, always remember to report the GFI, AGFI, TLI, CFI, and NFI. Alongside that, you must report the RMSEA and the RMR values. These are enough. Okay, these are enough along with the validation. So the AVE and the CR and the discriminant validity, these have to be reported. Now, let us go there to check the validation. So I told you that in the estimates, in the scalar, we will be using the standardized regression weights and the correlation. Okay, so now I will show you something very interesting. If you just, I do not know how many of you have used it, but I think you have already used it. There is, statistical package which is called at Wiki. If you go to this website, you will find one Excel tool which is called the statistical validation tool. Okay, you can download it. I am already having it with me. So let me open it. This is called the Stats Tools package. You visit that particular site called StatWiki and you download this Stat Tool package. See, there are several functions which you can perform, like the validation function can be performed. Two-way interactions can be checked, group differences can be checked, fit check can be done, the effects size can be estimated, data screening can be done, heterogeneity test can be done, outliers can be detected, the removing of the missing values or data row-wise or column-wise, imputation of the missing data, the scale assessment. Okay, so a lot of things can be done, but today we will be using it for the validation. Okay, so this is a Validity Master. This is the first page. So there are multiple number of sheets in this particular Excel tool. So we will be using the first sheet, okay, which is called the Validity Master. So what we need to plot over here, you see, the paste correlation table in A2. This is column A, this is row 2. So over here, we need to paste the correlation table and paste the standardized regression weights in table F2. So So this is column AF, this is row 2. We need to paste the standardized regression weights over here. And then we have to do a very simple thing. We need to just click this particular red tab, and everything will be calculated for you. All the validation issues will be calculated. So you need not worry. Okay, so I do not have to go for manual calculations, etc. Only for discriminant validity, you can go for manual computation based on the scores that you will get right now. Because discriminant validity, for discriminant validity, what you will have to use, you have to use the AVE. So the AVE, the average variance extracted, must be greater than the squared correlations between the construct. It will be displayed over here only. So we need to paste the correlation table over here. We need to paste the standardized regression table over here. So let us go back to Amos. Okay. You see, this is the correlation table. So you just select it and right click it, copy it. Fine. You go to this area. You just paste it over here. See, the correlation table is pasted. Fine. Go back to Amos. You go to standardized regression weights. Select it, right click it, copy it, go back here, just click this cell, standardized regression weights are pasted. So what we have done, we have pasted the correlation table over here, we have pasted the standardized regression weights over here. Now we simply have to click this, okay, this big red button. So we are clicking this. Fine. This line is very important for most of the scholars. No validity concerns. Fine. As I have told you, that you see, even with a non-robust kind of a model, you can have statistical, you can achieve statistical. So which one is more important? Sometimes I doubt whether the statistical significance is more important or usability of a particular model is becoming more important. So this is a trade-off between academic significance of a theory, academic significance of a model, and practical implication of a model. You see, the composite reliability, if I go here, sorry, the construct reliability, let me just go here in our slide. So, yeah. So construct reliability should be greater than 0.7. You see, the CR value, all are greater than 0.7, isn't it? 0.860, 0.934, 0.947, 0.868. The average variance extracted, just go back to the slide. What is the acceptable, reference? It should be greater than 0.5. It is much greater than 0.5. The maximum shared variance, it's also good. Then we are looking for this discriminant validity. We are seeing these diagonal values which are greater than each of the horizontal scores. Fine. Now, what is I told you that there is a problem with this particular model. You see how many latent constructs were there. You see, 1, 2, 3, 4, 5. Okay. Now, if you see this, the purchase intention and the purchase behavior was not considered in the model at all. So there must be certain issues with the data related to purchase behavior, which was overlooked when the EFA was conducted. Even, in case of a purchase intention, the diagonal value is not appearing. Okay, the relation between the purchase intention and attitude, the relation between the purchase intention and subjective norm, these data are also missing. Okay, so as a result of which we are achieving some kind of statistical significance or validation results with no validation issues at all. But when it comes to the practical application of this particular model, probably the scholar will fail to use this model to practically justify how the behavioral pattern is taking place. Because you see, if we, I don't have time to show you the structural model, or rather, let us put it like this. If I use structural equation, it will be too heavy for you. Let us see the structural model, at least the diagram. You see over here, This is the structural model. Otherwise, you see, this is the measurement model. This is the measurement model, means the scale measurement. Okay, where I have only measured the instrument. But when it comes to structural model, I have converted the interdependence technique into a dependence technique. You see, the same latent constructs were there. So out of the 5 latent constructs, 3 latent constructs were considered as independent variable. 1 latent construct has been considered to be a dependent variable, and another latent construct has been also considered as a dependent variable. So this particular dependent variable, which is purchase intention, it is almost like a mediator. It is creating a mediation between these set of independent variables and the dependent variable. Okay, so from interdependence technique, I am converting it into a dependent. So you know, this factor structure, or the underlying factor structure, the scholar is, the researcher is assuming that this kind of relationship may be shared with these 3 latent constructs playing the role of an independent variable, and these 2 latent constructs are playing the role of a mediator and a dependent variable respectively. Now you see, with the kind of validation issues that we are facing, the purchase behavior is totally going missing. And if it is your by default your dependent variable, if you cannot have any prediction about the dependent variable, then what is the practical use of this particular model? Although we are saying that there is no validation issues, the validation issues have been taken care of, but when it comes to explanation of the purchase behavior based on these 3 independent constructs, and the independent constructs are directly influencing this purchase behavior, plus it is making certain indirect contribution also through this. That means purchase intention is playing the role of a mediator. But unfortunately, we are not getting anything over here as far as the validation parameters are concerned. So statistically significant, but socially or realistically not relevant at all. So see, there is no problem with the CFA. CFA is actually validating what you have put it through the EFA process. Okay, so the actual fault should have been identified and pointed out and rectified in the EFA itself. It may be a case, because we have done so many EFAs, we have seen what exactly could have been the problem. A lot of variables which are not having significant correlational score were retained. Now, if you are not deleting those variables which are insignificant in terms of their correlational output, it will continuously disturb the output model. So you need to be very choosy which variables are to be retained. If you find a very poor correlational score, which is very insignificant, just delete that observed variable. Just delete it from the model. Don't keep it. Don't retain it. So for a scholar, it is absolutely essential to note that which variables are to be retained in the instrument or retained in the model, and which variables are to be discarded. All the statistical processes that you are applying, it will give you certain indication. That means which variables are to be retained and which variables are to be omitted. So if you are not omitting all those variables which are disturbing the basic nature of the model, then if you are retaining those disturbing variables and then you are proceeding for validation, there will be issues. Okay. So it is as simple as that. Fine. So with that note, we can end up over here. So in fact, CFA and EFA on a single day, it's pretty difficult to handle, and it's pretty difficult to digest also. So if you have any questions, you can go ahead and ask at this point. Thank you for your patient listening.